So right before we were in the shelter in place, we talked about something called reference angles. So let's just say I pick all the 30-degree angles. So for instance, let's talk about 30 degrees. Well, a 30-degree angle can be formed if we start here on the right part of the x-axis, and remember that 30 degrees is between 0 and 90 degrees. And this is pretty self-explanatory. A 30-degree angle in quadrant 1 is 30 degrees. So I can make a little note to myself right here that this is 30 degrees. And if we use our calculator, or we use the unit circle rather, we notice that the cosine of 30 degrees is the square root of 3 over 2, or if we plug it in the calculator, it's 0.866666666, sorry, not 0.866 repeating, but like 0.866, and then there's a few more decimal places, but this is the popular decimal notation. And if we take the sine of 30 degrees, it is equivalent to 1/2, or if we plug it in the calculator, we would get 0.5. Well, if we look for 30-degree angles in all 4 quadrants, these are the results that we get. So we take 150 degrees. Well, remember that we start here on the right part of the x-axis, and that creates 0 degrees, past the 90 degrees, and then just shy of 180 degrees. Now, why are the 30-degree angle and the 150-degree angle similar? It's because they meet up in quadrant 2, and they form a 30-degree angle when I sandwich them with the x-axis. So I sandwich this angle called the terminal point. Terminal meaning ending. So I sandwich the line that creates a terminal point with the x-axis, and this creates a 30-degree angle. Because if this black arc creates 150 degrees, then it sandwiches with the x-axis as a 30-degree angle. So therefore, we just notice that 180 degrees minus 150 degrees creates a 30-degree angle in quadrant 2. Now, remember that we use the cosine of 30 degrees is radical 3 over 2, and the sine of 30 degrees is 1/2, where we can use our calculator to get our decimals, 0.866 and 0.5 respectively. So I'm going to compare those results. Sorry, I moved the notebook by mistake. I'm going to compare those results with the cosine and sine of 150 degrees. I'm going to go to mode. I'm in degrees. Cool. So I'm going to do the cosine of 150 degrees, and I bet you that it is very, very similar to the decimal seen over here. So we've got negative 0.866, and I'm going to do the sine of 150 degrees, and I'm going to get something very, very similar. In fact, it's exactly identical. So the cosine has the same digits, the sine has the same digits, but the cosine is negative in quadrant 2, and the sine is positive in quadrant 2. So let me and that's how I can confirm that 150 degrees and 30 degrees are similar to each other. Okay, same thing over here with 210 degrees. Well, remember that we start on the right side of the x-axis, so 0 degrees is here, 90 degrees is here, 180 degrees is here, and it's a little over 180, but not quite 270. Remember, you go past 90, past 180, not quite 270, so we're in quadrant 3. This is our coterminal point. Sorry, this is our terminal point, and we want to sandwich it with the x-axis. So the 30-degree angle is actually right here, not on the y-axis. So when in doubt, just imagine a thick x-axis. Okay? So how do we know that it creates a 30-degree angle if we sandwich it with the x-axis? Well, remember that the angle itself, sorry, let me put the angle theta right here. Come on, where are you? So remember I put the angle theta here, And since it's past 180 and it sandwiches with 180, I can take 210 degrees minus 180 degrees and get 30 degrees in quadrant 3. Now, I'm going to compare the cosine and sine of 30 degrees with my cosine and sine of 210. So I'm going to get my calculator out. Come on, where are you? So I'm going to get it right there. Clear, clear, clear. So the cosine of 210 is negative 0.866. Very, very similar to the cosine of 30 degrees. Same decimals, but just negative. Oops, there we go. Sorry, I'm writing sideways. And then I'm going to compare that to the sine of 210. And that's negative 0.5. The same exact decimal, but just negative. And the reason why is because we are in quadrant 3. Finally, over here, remember we've got 330 degrees. So we started on the right side of the x-axis. That's a 0-degree angle. And there's 90, 180, 270, and 360. So if we go around this circle, past the 90-degree mark, past the 180-degree mark, past the 270-degree mark, and it's not quite 360, so this is the terminal point, and we want to figure out what angle does it form if I sandwich it with the x-axis. And just a spoiler alert, that's why it creates a 30-degree angle here. So what I'm going to do is I'm going to compare and contrast with the 30-degree angles, cosine and sine. And I'm going to get the following. So let me get my cosine of 330 degrees is positive 0.866. And my sine of 330 degrees is negative 1/2. So that's why, oh, sorry, I forgot to put over here. Let me get my black pen part. So that angle theta is formed because we went around 330 degrees. We wanted to complete the circle. So in a way, this is 360 degrees minus the quadrant 4 angle. And that's why we get 30 degrees in quadrant 4. All right, so if you just want to see the whole thing. So refresh my memory, we had this thing called the unit circle. And if you go on Wikipedia and you type in unit circle, you'll see this big image. It's really, really awesome. It spaces them out in blue and red. But I kind of like what I got going on right here. So obviously I'm not a perfect artist. I tried to draw a circle, and so it ended up looking like an egg. So I had to shade over it and go, good enough. But the purpose of it is you start here. You start on the right side of the x-axis, creating a 0-degree angle. And then you go counterclockwise to create a 90-degree angle. And then you go 180 degrees, and then 270 degrees, and I'm drawing it lightly. And then a full rotation would be 360 degrees. And on top of that, so not only do you have the axes, you start out at 0, 0, and and the radius is 1. So if I go to the right, it creates 1, 0. If I go up, it creates 0, 1 as its point. If I go to the left, I get negative 1, 0. And if I go down, I go 0, negative 1. And that's how we create what's called the unit circle. Remember, uni means 1. So it's a circle of radius 1. And uni, think words that start with uni. Unicycle, unicorn, uniform. Everybody's wearing the same clothes. Uniform. Everybody's wearing one outfit. And so on and so forth. So uni technically means 1. How many ones do I have if I calculate it in inches, feet, centimeters, yards, and so on and so forth? We establish what 1 inch is or 1 centimeter is, and we count the ones. So you never thought about that, did you? Like units. How many ones are there? Anyway, so what do we care about the unit circle? So the unit circle basically shows all the reference angles for 30 degrees, 45 degrees, and 60 degrees. So if you remember from the unit circle when we did this in class, hang on, let me get my pencil really quick. You'll notice that you don't have to draw this part, I just want to show you that we can create a 45-degree angle. Sorry about that, I'm drawing this quick. And then we can create 30 degrees. Right. If you wanted to leave it with the circle, that's fine as well. But the idea is you have 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then you've got 120, 135, 150, and so on and so forth. So you show all the reference angles of 30 degrees, 45 degrees, and 60 degrees, as well as the axes. So the axes are the 0-degree mark, the 90-degree mark, the 180-degree mark, 270, and a full rotation, which is back to 0. But I just put in there just because 360. But that's the idea of the unit circle. I don't want you guys looking at the unit circle and thinking, oh man, I hope I remember what the cosine and sine of 210 degrees are. I'd rather you know where it comes from and what the intent is. The intent of the unit circle is to know that if you're in quadrant 1, quadrant 2, quadrant 3, and quadrant 4, that you should get these relationships. So we have the x being the cosine of the terminal point, and the y being the sine of the terminal point. So if you go back to Algebra 1, let me get a good... So if you go back to Algebra 1, you had the Cartesian coordinate plane, and we called this quadrant 1, 2, 3, and 4. So we had an x and a y for all 4 of them. And if we're in quadrant 1, remember that x is the cosine and y is the sine. So in quadrant 1, we have a positive cosine and also a positive sine. Okay? Right is positive, up is positive, so upright is positive, comma, positive. Now you go back to quadrant 2, the x should be negative and the y should still be positive. So remember that x is cosine, so we've got a negative cosine of theta and a positive sine of theta. And finally, in quadrant 3, remember, go back to Algebra 1, this is where x is negative and y is negative. So that would mean that in quadrant 3, your angle should have a negative cosine and a negative sine. And in quadrant 4, remember, we're going right and down, so down right. Remember that if we're going right, that would mean that the cosine is positive and that the sine is negative. Okay. So how do you find reference angles? Well, if the angle is between 0 degrees and 90 degrees, then the reference angle would be itself. After all, we're trying to figure out an angle between 0 and 90 degrees in one of the 4 quadrants. Because even though the goal of sine, cosine, and tangent are to have, the goal of sine, cosine, and tangent are to solve the unknown side lengths of a right triangle, you plug in the calculator 91 degrees even. Well, There's no right triangle with 91 degrees. But there is an 89-degree angle in quadrant 2, though. But we're in quadrant 1, so the reference angle is obviously itself. We can calculate cosine and sine in quadrant 1. Therefore, quadrant 2, the reference angle is formed if you have an angle between 90 and 180 degrees, and you can find that reference angle by drawing a picture. Okay, draw a picture, and you will sandwich the terminal point with the x-axis. So if you draw an angle between 90 and 180, and you sandwich it with that terminal point, you're trying to complete 180 degrees. So this angle plus theta should be 180 degrees, or the reference angle is equal to 180 degrees minus the angle in quadrant 2. And if you're concerned, did I do this right? I want you to get your calculator and plug in the quadrant 2 angle, cosine and sine, and compare it with the reference angle. And you should get the cosine of, the cosine of the angle is negative, and the sine of the angle is still positive. Same exact digits. Okay. If your angle is between 180 degrees and 270 degrees, you're in quadrant 3. So if you draw your picture and you end up in quadrant 3, you're sandwiching the terminal point with the x-axis and forming this angle theta. Now remember that your angle is over 180 degrees and you're sandwiching it with the angle with the x-axis. So we have to take this quadrant 3 angle and subtract 180 degrees from it to figure out what this part is. And how do you check your work if you did it correctly? Compare the cosine and sine of the quadrant 3 angle with the cosine and sine of your reference angle, and you should get a negative cosine and a negative sine. Okay. And for quadrant 4, if you have an angle that's over 270 degrees and you want to sandwich it from the terminal point to the x-axis, you create the angle theta here. So if it's between 270 and 360 and I want to sandwich it with the x-axis, remember that a full rotation is 360 degrees. So it's almost like I take the entire circle and I subtract the part where the terminal point ends, so leaving me with this tiny slice of pizza. And the way I can do that is I take 360 degrees minus the quadrant 4 angle. And fear not, how do you know if you have the correct reference angle, even if you do the work? Well, compare the cosine and sine of the reference angle with the cosine and sine of quadrant 4. So since the terminal point ends on the right side, that would mean that the cosine of quadrant 4 angle should be positive. But since the angle is below, it's still down, the y-coordinate, or the sine of quadrant 4 angle, should be negative. Okay. We're going to be doing some reference angle review tomorrow, and then we'll get into why I'm reviewing the trig ratios and the inverse trig functions, as well as going over the reference angles before we get into the heavy duty stuff. All right. Have a great day, guys.